In this video, I'm going to walk through the first 6 problems of the problem set with you and draw some pictures that will help you, mark up diagrams, and walk you through some of the first steps. So here's number 1. Write a similarity statement for the triangles on the right. Start by marking congruent angles. These little arrow markings tell us that segment AB is parallel to segment EC. So we have that corresponding angles are congruent. So when we write a similarity statement, we can just fill in the blanks here. We write triangle ABD is similar to, and then when you write out the second triangle, make sure that you match up corresponding angles or corresponding vertices in the order of ABD. And then in this blank, we need to think about how we know they're similar. Notice that we only have information about the angles here. It looks like we have 2 pairs of congruent angles in triangles ABD and triangles ECD. Let's look at problem 2. So this says, show that triangles on the right are similar by SAS. And we're going to start by redrawing the triangles separately. So to do that, first what I'm going to do is trace each triangle. What I recommend you do is just copy these triangles on notebook paper. You can also try to use Sketchpad or Google Draw. I'm tracing the smaller triangle now. And after I have these triangles traced, I'm going to label the vertices and the given side lengths. Okay, here are my 2 triangles. Now let's look at side OR. It looks like side OR has a length of 24 and side OS has a length of 16. Side OP has a length of 8 and side OQ has a length of 12. Now that the triangles look like this, it's easier to see that we have SAS similarity because we see that we have a shared included angle and we have corresponding sides related by the same scale factor. So what you need to do is show that OR divided by OQ is equal to OS divided by OP. In other words, show that these triangles are related by, show that the side lengths of these triangles are related by the same scale factor. So what remains to be done in this problem after you draw this picture is to write a sentence putting together what this tells you. In your explanation, calculate OR over OQ and OS over OP and point out that both triangles share angle O. Okay, let's look at the third problem together. This asks us, are any of the right triangles below similar to each other? Explain why or why not. And again, in this problem, it's a lot easier if we redraw the triangles separately. Okay, there's triangle JKL. Here's triangle JMK. And now here's triangle KML. Okay, so the first thing to notice is that all of these triangles are right triangles. So I'm going to mark all of the right angles that I have. This is a right angle. This is a right angle. This is a right angle. Now let's look for shared angles. So I see that in triangle JMK and in triangle JKL, angle J is shared. So that means that these angles are congruent. So I know that triangle JKL is similar to triangle JMK by angle-angle similarity, and you need to write that out. In your explanation, you can say triangle JKL is similar to triangle JMK. But now let's look at the third triangle. Triangle JKL and triangle KML share angle L. So we know that triangle KML is similar to triangle JKL by angle-angle similarity. But now, since we know that these two triangles are similar, and we know that these two triangles are similar, it follows that all three triangles are similar to each other. So what you should do is write out a similarity statement that looks like triangle blank is similar to triangle blank is similar to triangle blank by angle-angle similarity. Let's look at the fourth problem now. We're given that figures P and Q are similar. In part A, we're asked, what is the ratio of similarity between figure P and figure Q? So because we're asked for the ratios of similarity between figure P and figure Q, so let's look at corresponding side lengths. That shows us the ratio is 3 to 7, which we could also represent as 3/7. What I want to point out is there's another way to ask this question. If you were to ask, what is the scale factor that takes figure P to figure Q, then you would answer that question as 7/3. But if we're asked, what is the ratio of similarity between figure P and figure Q, the way we want to think about that is what is the ratio of the side lengths of figure P to the side lengths of figure Q. And that ratio is 3 to 7, which we could also represent as 3/7. So now, to find the perimeter of figure P, all we want to do is add up the side length. Say perimeter P equals. And write out what you get when you add up these side lengths. In part C, it tells us use your previous two answers to find the perimeter of figure Q. So we know that the ratio of the side lengths of figure P to the side lengths of figure Q is 3 to 7. So that means that the perimeter of figure Q is equal to 7/3 multiplied by the perimeter of figure P. Another way of saying this is the perimeter of figure P is equal to 3/7 multiplied by the perimeter of figure Q. We know we're going to have to multiply the perimeter of figure P by a number bigger than 1 to get the perimeter of figure Q. Perimeter scales the same way that the side lengths scale. Now it says find the ratio of the areas by squaring the ratio of similarity. So what you're going to calculate is 3/7 squared, and I'll go ahead and do that with you. That's 9/49. So that means that the ratio of the areas is 9 to 49. The area of figure Q is equal to 49/9 multiplied by the area of figure P. And we know that because we know that the ratio of the areas is 9 to 49. And since we want the area of figure Q, we want to know how do we scale the area to go from the area of figure P to the area of figure Q. The way we do that is by multiplying by 49/9. Since we know that the area of figure P, one more time, since we know that the ratio of the areas is 9 to 49, one more time, you will notice that angle B and angle E are congruent. Also, angle E and angle D are congruent because we have alternate interior angles that are congruent. We know this because sides AB and DE are parallel lines cut by transversal AD. So this gives us congruent alternate interior angles. We also know that angle ACB is congruent to angle DCE because they are vertical. So let's start by writing out the similarity statement. So we need to go in order. So we have ACB is similar to DCE by angle-angle similarity. So we've marked up the angles, we wrote a similarity statement, and we said how we know the triangles are similar. And now we want to write out a proportionality statement about the side lengths or calculate the scale factor. So I'm going to do this in two ways. Now that I have a similarity statement, what I can do is solve for AC and BC. The easiest way to do this is to notice that the scale factor relating the side lengths of the smaller triangle to the larger triangle is 3. ED over BA equals 21/7, which is 3. This is the scale factor. So what that means is I can identify the side that corresponds to AC in the larger triangle. I see that that's DC. and I can divide by 3. So DC divided by 3 is equal to AC. And that gives us 16 divided by 3 equals AC, and it's totally fine to leave my answer just like that, 16 divided by 3. I know that's true because AC and DC are corresponding sides in similar triangles, and I know that the scale factor relating the side lengths of these triangles is 3. So if I divide DC by 3, I get AC. Let's do this to find BC. Now I want the length of BC. I know that BC corresponds to EC. BC equals EC divided by 3. So BC equals 12 divided by 3, which is 4. In number 6, we only need to calculate the length of HJ. We don't need to calculate the length of FI. I'm going to make that correction in the document. So first notice that GI and HJ are parallel. This tells us that these angles are congruent and these angles are congruent because we have corresponding angles formed by parallel lines cut by a transversal. So now we can write a triangle similarity statement. We're going to say triangle FGI is similar to triangle FHJ by angle-angle similarity because we have two pairs of congruent angles. In order to find HJ, we are going to write and solve a proportionality statement. So what we can do is we can start by noticing that FG and FH are corresponding sides, and GI and HJ are corresponding sides. This means that FG over FH equals GI over HJ. When we substitute, we get 4 over 13 equals 7 over HJ, and we'll just call that X. Previously, when you've solved proportions, you might have done something like multiply 4 by X and set that equal to 7 multiplied by 13. That procedure works. I just want to point out that what we're actually doing algebraically is we're multiplying both sides of the equation by both denominators to clear the denominators. So when we multiply both sides by 13x, we get the x is canceling here, the 13's canceling here, and that gives us 4x equals 7 multiplied by 13. So x is equal to 7 multiplied by 13 over 4, and that answer goes here.